So our gravitational energy is mgh. Work done by non-conservative forces, we've got the friction force times the distance times the cosine of the angle between them, which is 180 degrees because delta x is down the incline, the friction force is up the incline, and that's where our negative sign comes from. And our elastic potential energy, 1/2 k x squared, or I'm calling it delta x in this case. So what do we need? We need, I'll just write out one more line here, mgh minus the friction force is mu sub k times the normal force So we need to find out what our normal force is. That's just the weight in the y direction. And our height, h, is just delta x times the sine of theta. Let me draw that out where that comes from real quickly here. The block starts out here in the initial state. It ends up here in the final state. So we want to know how much does it change in height. And the hypotenuse is delta x. The hypotenuse is delta x. This side is h. And the angle is theta. So the sine of that angle is going to be h over delta x, or h is equal to delta x sine theta. So we plug in here, what do I end up with? mg sine theta delta x minus mu sub k mg cosine theta delta x equals 1/2 k delta x squared. And as long as delta x is not 0, we can divide through by a delta x and get rid of 1. And what am I left with? I'm left with 2 over k times mg times sine theta minus mu sub k cosine theta is equal to delta x. I get 27.0 meters. It's a long way. Okay, so we know that it slides down the incline. Remember, you have to use your coefficient of kinetic friction while it's sliding down the incline, mu sub k. We get 27 meters. And now let's see if it stays there. Is it comes to rest momentarily at that point? Is the spring gonna pull it back up the incline, or is it just gonna sit there? Let's take a look. So at the bottom, we've got the block. There's a normal force up. There's a weight in the y direction down. There's a spring pulling up the incline. And there's a weight in the x direction pulling down the incline. And there's one other force now. If this thing wants to go up the incline because of the spring, a static friction force will pop up opposing that. So let's see if the spring force is greater than the weight in the x direction plus the maximum static friction force, it goes back up. If not, it stays there. So let's take a quick look. What's our spring force? That's equal to kx. And so I plugged in 27 meters for x and 30 newtons per meter for k, and I get 810 newtons. The weight in the x direction we found earlier, it doesn't change as it goes up and down the incline, 630 newtons. And our maximum static friction force we found earlier, that's 450 newtons. So the spring force is less than the weight in the x direction plus the maximum static friction force. It stays at rest at the bottom.